So for this video, we'll be talking about the greatest common factor. So let's start. So when we say factor out here, what we mean by that is that this is a number that divides another number. Let's denote that by D. And if D is a factor of A, then we can write D divides A. Moreover, we also another term for factor is divisor. Now when we say common factor, that means that if we have two numbers A and B, then that means that D divides A and D divides B, since D is a common divisor of A and B. So now, let's get that out of the way. So when we say the greatest common divisor, this is the greatest D that divides two or more numbers. Let's have an example. Say we have 2. Since 2 divides 4, then 2 is a factor of 4. Also, since 2 divides 8, then 2 is also a factor of 8. So 2 is a common factor of both 4 and 8. But if we get the greatest common factor, we will have in 4 and 8, their common factor is actually 4, since 4 divides 4 and 4 divides 8. So that is the difference between a common factor and the greatest common factor. Let us try another example. Say we have 12 and 18. To get the greatest common factor, the first thing that we can do is to list out the factors of the number. So for this one, 12 has a factor of 1, 2, 3, 4, 6, and 12. For 18, we have 1, 2, 3, 6, 9, and 18. Observe that in here, both 2, also 1 and 3, and also 6 are common factors of 12 and 18. But since we are asked for the greatest, we know, that the GCF of 12 and 18 is actually 6. So that is our first method, the listing method. Let's go on to another example. Say if we have 6 and 7. Let's try to list out their multiples. We have 1, 2, 3, and 6. For this one, we only have 1 and 7, since 7 is a prime. Observe here that the only common factor between 6 and 7 is actually 1. So, the GCF of 6 and 7 is 1. When this happens, we say that 6 and 7 are relatively prime. So take note of that term. similar in the LCM, we will present two methods in finding the GCF, especially when the number is now larger. So first, we have the factor 3 method. So say if we have 24 and 60, we first apply the factor 3 on the two numbers. So for this, we have 8 and 3. This one is 4, 2, and 2, 2. This one is 6, 10, 2, 3, and 2, 5. Let's move this first. Now, if we can write 24 and 60 in its prime factors. So we have 24 is equal to 2 cubed times 3, and 60 is equal to 2 squared times 3 times 5. In finding the greatest common factor, what we do is we check which of the factors here has the lower exponent. So it's the opposite in LCMs, where when we apply this method, we try to check which among the factors has the higher exponent. So for this one, for the 2, we know that 2 raised to 2 it has the lower exponent. So we circle that out. For the both 3's, we can choose either since they both have the same exponent. How about for 5? Note that in 24, we have 5 raised to 0 out here. So since 5 raised to 0 is 1, so that is the one that we circle out. So we have the GCF of 24 and 60 is equal to 2 squared times 3 times 5 raised to 0, or we can simply remove that one. This would give us 4 times 3, which is 12. So that is our first method. For our next method, similar to the LCMs, this is the division, the continuous division method. Let's write that down. Continuous division. So let's try 3 numbers this time. Say we have 30, 90, and 225. So for this one, let's put this one out here. First, we check what factor is present in all these 3. Clearly, 5 is a factor of all of them, since all these numbers ends in 0 or 5. So, let's put out 5 out here. This would give us 6. 5 divided by 90 would, let's try to calculate that down. This would give us 18, and 225 divided by 5, what would this give us? That is actually 45. Now what else can we factor in here? We can also factor 3, since all these are divisible by 3. Clearly, 6 is divisible by 3. 1 plus 8 is equal to 9. So that is divisible by 3 by the divisibility rule. The same goes for 45. So we have 2. So we have 2 and 6 and 15. Now observe that here in the bottom part, there are no more factors that are similar to all 3 of them. Now note that even those even though this 2 has a similar factor of 3 and this one has a similar factor of 2, we won't be needing to factor that out anymore, since what we are finding is the common factor in this 3. So we simply take this 2 and so we multiply that one. So we have the GCF of 30, 90, 125 is equal to 3 times 5 or 15. And that is our final answer. So we have presented 3 methods in this one: the listing method, the factor tree method, and the continuous division method. Also, we defined the terms factor, common factor, and the greatest common factor. In the next video, we will try to show more examples on this lesson. So, that is all for this video.